Hello everyone, my name is Omid Latifi and I'm joined by Pratik Das, and today I'm presenting Arctic Overwatch, an end-to-end Canadian Arctic dark vessel surveillance system. Before we dive in, a quick introduction. Our team consists of myself, I'm the product manager of Arctic Overwatch, and Pratik Das, our AI engineer and lead developer. So let's talk about the problem. Canada has one of the longest Arctic coastlines in the world, yet it has some of the weakest maritime surveillance coverage. Climate change is opening new shipping corridors faster than our oversight frameworks can keep up, and right now, no single system gives Canada a unified, real-time picture of what is happening in its Arctic waters. This is a massive national security gap, and that gap is being exploited. Russia's shadow fleet has grown from fewer than 100 vessels in early 2022 to over 500 by 2025, now representing roughly 17% of the global tanker fleet. In 2025 alone, 100 sanctioned vessels transited from Russia's northern sea route, up from just 13 the year before. Overall, Arctic ship traffic has increased 40% since 2013, and crude oil tanker movements have quadrupled. These are vessels deliberately evading detection, and the trend is accelerating. So how do we see what traditional systems cannot? We use synthetic aperture radar, or SAR imagery. SAR works regardless of weather, cloud cover, or polar darkness, making it ideal for the Arctic environment. But here's the key innovation. Every vessel creates a unique wake pattern determined by its hull design, mass, and speed, essentially what ship design it is. These are physical properties that cannot be spoofed or switched off in a way that AIS transponders can. We trained a custom YOLO VA detection model on 458 proprietary Skywatch-provided SAR images, inspired by research from the University of Bristol on physics-informed diffusion models. Our model extracts geometric features like the Kelvin angle, width, turbulence pattern, and wake length to determine what we call a wake fingerprint. To address training data scarcity, we leveraged a physics-based simulator to generate synthetic SAR wake images, which were then refined through a diffusion model. This allowed our detector to generalize across varied Arctic sea states and vessel headings. Here you can see 3 examples of our model detecting and fingerprinting different wake patterns from real SAR imagery. Each wake gets a unique identifier. The validation pipeline is straightforward. We start with raw SAR data, reduce noise through speckle filtering and ice clutter removal, run our AI-based wake detection, generate a unique fingerprint, and then validate the ship by cross-referencing against AIS records. Here is the full end-to-end data flow. Skywatch's API brokers on-demand SAR imagery from providers like IceEye and Capella. We clean the image, run detection, cross-reference against AIS, and if there is a mismatch or no AIS record at all, we flag it as a dark vessel. That alert goes straight to the dashboard, triggering escalation to DND or the Coast Guard. Our initial region of interest is Lancaster Sound in Nunavut, a critical choke point in the Northwest Passage. And now we will be taking a look at how Arctic Overwatch works from an end user's perspective. As you can see, we have a 3D global notification system of every shipping route in the world. And when something suspicious is detected, it immediately shows up both in the user interface and the notification panel. And when we click upon the notification panel, we can see that particular region in much higher detail. Analyze Lancaster Strait.
The high Arctic had the most maritime detections with 6. Some vessels may be operating secretly or trying to evade sanctions, as their wake signatures don't match their claimed identities.
Now, how does this compare to existing systems? The traditional RCM/iSlop pipeline takes 70 to 90 plus minutes from satellite pass to investigation, and it only works if the vessel is broadcasting AIS. If a ship turns off its transponder, the traditional system generates no alert at all. Arctic Overwatch achieves an estimated 15 to 30 minute end-to-end latency, and it detects dark vessels regardless of AIS status. That is up to 6 times faster, with no dependency on cooperative targets. For the environment, the stakes are enormous. With roughly 500 sanctioned vessels operating as dark ships, a 2% spill rate, and an average cleanup cost of about $5.9 billion per incident, we estimate $49 billion in potential savings through early detection. These aging vessels, typically 15 to 20 years old, carry no insurance, meaning the full financial burden of a spill falls on an affected nation like Canada. Arctic Overwatch directly supports 4 UN Sustainable Development Goals, protecting maritime life, strengthening institutions and sovereignty, reducing inequalities for Indigenous communities in the North, and promoting responsible economic growth. We are proud to say that Arctic Overwatch won Canada's first ever military defense tech hackathon and has been featured in the Globe and Mail, Icebreaker, Space Q, and Lakehead University. Thank you for listening.